All right, we're going to go look at quadratics and finding the maximum height of a quadratic. So it says when Joey dived off a diving board, the equation of the pathway can be modeled by negative 16t squared plus 15t plus 12. So the first thing I'm going to do is I'm just going to sketch out a picture so we kind of understand what is happening here. We got Joey, he's up on a diving board, okay, and he's right about here, we'll say 12 or 12 feet or whatever, okay? And Joey's up there, and Joey is getting ready to jump off the diving board into a beautiful, luxurious Florida pool. And when he does so, he is going to have a path that goes up and comes back down. And when he does that, it is going to splash, and he is going to have so much fun. Now, what we're going to do is we're going to calculate how high he actually goes. So what we are going to do is we're going to locate the highest point he actually goes. Now, when we do this, the first thing that we are going to calculate is not the height, but we are going to find the line right down the middle, which is called the axis of symmetry. Everybody gets really excited when we say that. The axis of symmetry is simple. It is x equals negative b over 2a. And one of the things in this problem you're going to notice is there's no x's. There's t's. Those x's are the same thing as t's. So we do have to remember that. This is going to be time down here. And this is going to be height. Okay, and time is going to be where our x values are in the equation. So it's simple. The negative simply means the opposite. Okay, so the negative just simply means the opposite. And so what we're going to do is we're going to write it in just like that. We're going to say the opposite negative, which is the opposite right there, of b. And this is a, then b, then c. So I'm going to put the opposite of 15, which is negative 15, all over, and then we just write in 2 times a. A is negative 16. The important part is that you make the b value its opposite value. Now, once we have that, we just have negative 15 all over 2 times negative 16, which is negative 32. Now, I'm going to be honest, I don't know that decimal by heart, so I'm going to go off to Desmos. I'm going to cheat. I'm going to use a calculator, and I'm going to simply type in negative 15 divided by negative. And that is going to give us 0.468. Let's go ahead and round that to 0.47. To 0.47. Okay. Now, when we're doing this, we've got x equals 0.47, which is our time. What that means is that this axis of symmetry right here happens at 0.47. That is when x is happening, our time is happening. And we're going to use that to calculate how high it actually goes. Okay, and what we do at this point is we just simply plug it into the equation. So we say h equals negative 16, 0.47 squared. Notice I put that right in there, plus 15 times 0.47. Once again, put it right where the variable is. And then I'm going to put plus 12. Now, I go off to Desmos because Desmos is my friend, and I am going to type that in. Negative 16 times 0.47 squared plus 15 times 0.47 plus 12. And notice what happens. The answer comes out to be 15.515 or 15.5. So the height is 15.52, and maybe it's in feet. We'll say our measurement is in feet. I'm going to say it is 15.52 feet. That is exactly how high Joey has been when he dives off that jumping board. Now, we've done this by hand. It's always great to check our work with a calculator. So I'm going to go off to Desmos, and I'm going to turn on the graph in Desmos. Desmos is our friend. And once again, I'm going to focus in on the idea. If you remember, one of the things I said was Joey was 12 feet in the air when he started, and there he is on the y-axis. And he jumps off of that diving board, and he goes right up. And then before he comes right back down to hit the water down here at the bottom. But the important part is how high is he? So I'm going to click on it. you'll notice 0.469 or 0.47 and 15.516 or 15.52. All right, that's how we find the maximum height using the axis of symmetry and then plugging it into the equation to find the height.